Welcome back. We're going to do power of a power property. So we're going to look at this. We're going to start with the inside of the parenthesis first. Inside of the parenthesis, it says that there are 3 2's that we need to write down. Then on the outside of that, it says we're going to write that 2 different times. So you could think of it as this saying this right here, where we're writing 2 to the third 2 different times. So I have 2 times 2 times 2, and then 2 times 2 times 2. That would get me 2 to the 6th power. This one says I have x to the 4th times x to the 4th times x to the 4th. So if I write it in expanded form, I have 4x's there, 4x's here, and 4 more x's here. And when I do that, you get x to the 12th power. On this one, it's the same thing as saying 3 squared times 3 squared times 3 squared times 3 squared. That's what it means to be to the 4th power. So I'm going to write it all out. So I have 2 3's, I have 2 more 3's, I have 2 more 3's, and lastly, I have 2 more 3's. So how many 3's do I have? I have 8 3's. This one is saying x to the 5th times x to the 5th times x to the 5th times x to the 5th. And what are we going to do with this? We're going to write it out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And lastly, 1, 2, 3, 4, 5. How many do we have? We have 20 of them. So this down here is 15 to the 3rd times 15 to the 3rd times 15 to the 3rd. So 15 times 15 times 15. 15 times 15 times 15. And last but not least, 15 times 15 times 15. So how many 15's are there? There are 9. Okay, so I'm actually going to take away that for a minute. We're going to compare these exponents to each other. The bases are exactly the same. The bases didn't change, but the exponents, what happened to the exponents? What happened to the exponents? Let's look here. I have 3 and 4 for my exponents, and I got 12. I have 2 and 4, and I got 8. I have 5 and 4, I have 20. I have 3 and 3, and I have 9. So hopefully you notice that what's happening is we're multiplying the exponents. So we have a to the m times n. So this would have been 2. I write my base down. Oops, sorry, I don't know why it did that. Write my base down, and I multiply my exponents. That would still get me 2 to the 6th. I write down my base, and I multiply my exponents. I write down my base, and I multiply my exponents. I write down my base, I multiply my exponents. I write down my base, and I multiply my exponents. So let's look at this one. This says that it's 5y to the 4th written 2 times. Okay, so I write 5, y, 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 and 5, y, 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 y. So how many 5's are there? There are 2 5's. How many y's are there? There are 8 of them. On this one, 2 times 3, 2 times 3, 2 times 3, and 2 times 3. How many 2's did I get? 4. How many 3's did I get? 4. We're not multiplying this all the way out because we're trying to find the rule. That's why it's not having us do that. 4y to the third times 4y to the third times 4y to the third. That's what this means. So if I write that all out, 4, 1, 2, 3 times 4, 1, 2, 3 times 4, 1, 2, 3. So I get 4 to the third power because there's 1, 2, 3 of them. And I get y to the ninth power. The next one, 5 to the third x squared, 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 1, 2, 3, 4, 5 to the third x squared. Okay, so I expand that. I get 1, 2, 3, 1, 2. Then I get 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And lastly, 1, 2, 3, 2. So how many 5's are there? There are 15 5's. How many x's are there? There are 10. And last but certainly not least, it says that squared, so 2x to the third y to the fourth times 2x to the third y to the fourth. So I get 2, 1, 2, 3, 1, 2, 3, 4 times 2, 1, 2, 3, 2, 3, 4. So I get 2 squared. I get x to the third, y to the fourth. Oh, not fourth, to the eighth. Sorry about that. Oh, how about I get rid of that? Eighth. Oh, I messed up on that one. Sorry, guys. There are not 3. There are 6 x's. Thank you. I'm sure somebody at home is saying, why did she do that? Because she's tired. Okay. So if I look at these, remember there's an invisible 1, invisible 1's for these exponents right here. So if I look at these exponents, and I look at these exponents, I look at these exponents, I look at these exponents. Okay, a minute ago, we talked about multiplying the exponents. Is that what's happening? Well, let's look. So, I have 5 to the 1 times 2, and y to the 4 times 2. Well, 1 times 2 is 2. That's what I have there. 4 times 2 is 8. Yep, that equals each other. So let's, I put equal sign before we proved it. So 1 times 4, 1 times 4. 1 times 4 is going to get 4. So these two are equal to each other. This one has 4 to the 1 times 3, y to the 3 times 3. So the property shows it would work. This one, I'm going to do right here, 5 to the 3 times 5, x to the 2 times 5. 3 times 5 got the 15 that's right here. 2 times 5 got the 10 that's right there. And last but certainly not least on this one, I would have 2 to the 1 times 2, x to the 3 times 2, and y to the 4 times 2. 1 times 2 gets this 2. 3 times 2 gets this 6. 4 times 2 gets this 8. So yes, they are equal to each other. So what this says is that I'm going to multiply the exponents. going to multiply the exponents. Okay. Now we're going to go to 103, I believe. 2, 3. So, we just talked about this and what it means. So I have 6 to the 4th, 6 to the 4th, 6 to the 4th, 6 to the 4th, and 6 to the 4th, which also means 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And lastly, 1, 2, 3, 4. When I do that, I count all those up and I have 26s. So, to find the power of a power, you multiply exponents. You will be multiplying the exponents. So, 1, 2. Oh, I'm gonna write it the other way first. So this is the same thing as 8 to the 4th times 8 to the 4th times 8 to the 4th. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So that would get me 8 to the 12th power. Now, if I went by the property, I would multiply 4 times 3, and those are equal to each other. This next one, okay? Do I really want to write all that out? I don't. I'm just going to multiply them. You would take 7 times 5, and you would get k to the 35th. You would take 5 times 2, and you would get 2 to the 10th. You would get 6 times 4, and you would get 24. Here, it's a power raised to a power raised to a power. So, you multiply. So that's 3 to the 6th times 2, so 3 to the 12th. On this one, what does this mean? It means 6x squared written 3 times. So this is the same thing as 6xx, 6xx, and 6xx. So that would get me 6 to the 3rd because there are 3 6's. And that would get me 2, 4, 6 x's. Now if I was to do the rule, there's an invisible 1 right there. So 6 to the 1 times 3, x to the 2 times 3. 1 times 3 gets this 3. 2 times 3 gets this 6. So it does work. The exponent on the outside goes to every base that is on the inside. If it's already has an exponent, multiply the exponent. So, 3a squared times 3a squared times 3a squared, 3a squared times 3a squared. So 3aa, 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 and 3aa. So this would get me 3 to the 5th power, a to the 10th power. But if you were to show the property, there's an invisible 1 there, so it would be 3 to the 1 times 5, a to the 2 times 5. 1 times 5 gets 5. 2 times 5 gets 10. So those are equal to each other. Okay, so this says 4p to the third times 4p to the third times 4p to the third times 4p to the third. If I multiply this out, 4p, p, p, 4p, p, p, 4p, p, p, and 4p, p, p. Okay. That would get me 4 to the 4th power. It would get me p to the 12th power. If I was to show the rule for this, remember this has an exponent of 1. 4 to the 1 times 4. Oops, I didn't mean to write it there. 4 to the 1 times 4, p to the 3 times 4. 1 times 4 gets 4, 3 times 4 gets 12. So this is my answer. And no, you don't need those little lines underneath. I was just showing. Okay? So, boys and girls, this -2, the whole number -2, is raised to the 5th power. So that's 1 times 5. M, 7 times 5. N, 6 times 5. So -2 to the 5th power, m to the 35th power, n to the 30th power. Okay, so this one has so I had 8 squared. Oh, that's okay. And this would be to the 18th. So 8, 1 times 2, b, 9 times 2. And they equal each other. So again, this has an exponent of 1. So 6 to the 1 times 4. X to the 5 times 4. Y to the 11 times 4. So you get 6 to the 4th, x to the 20th, y to the 44th. This one, I have -5 raised to the 1 times 3, w 2 times 3, and z 8 times 3. So I would get -5 to the 3rd, w to the 6th, z to the 24th. Again, this has an invisible 1. 1 times 3, 4 times 3, 5 times 3. 2 to the 3rd power, m to the 12th power, n to the 2nd power. Okay. This one. There's an invisible 1 here and an invisible 1 here. 1 to the 5th, 1 times 5 power over 2 to the 1 times 5 power. So I'd get 1 to the 5th over 2 to the 5th. 1 to any power is going to be 1. And then 2 to the 5th is 32. Okay. -5 raised to the 1 times 3. 4 raised to the 1 times 3. That would get me -5 to the 3rd power over 4 to the 3rd power. This would get me -125. This would get me 64. Okay, multiply my exponents. 3 times 7. 4 times 7. X to the 21st, y to the 28th. Okay, again, I multiply exponents. I would get a to the 6th, b to the 2nd. Okay, Almost there. So we would be multiplying exponents. So 3 times question mark equals 4 to the 12th. So the bases are the same already, so I need to solve for my question mark. If I divide both sides by 3, question mark equals 4. Okay, over here. 1 to the question mark times 10 equals 1 to the 10th. This should be pretty straightforward, guys. Divide by 10. I meant this problem. Okay. Really hope that helped.